Section 4.6, Uniform Motion Problems. We're going to use the formula D equals R times T. That's D stands for distance, R stands for rate, and T stands for time. Our rate is constant, always the same. That's why it is a uniform motion problem. Example 1. Two cars, the first traveling 10 miles per hour faster than the second, start at the same time from the same point and travel in opposite directions. In 3 hours, they are 288 miles apart. Find the rate of the second car. We know car 2, well, let's say we know car 1 is going 10 miles faster than car 2. So we'll name car 2 X for the rate, and car 1's rate is going to be X plus 10. Both cars traveled for 3 hours. Car 1 went this way, car 2 went this way, opposite directions. The total distance they traveled is 288 miles. Distance equals rate times time, so I can write in 3 times x plus 10. Here I can write 3x. We want to add those two distances, and those two distances are going to total 288 miles. So we've got 3 times x plus 10 plus 3x equals 288. Distribute. 3x plus 30 plus 3x equals 288. 6x plus 30 equals 288. Subtract 30, and we have 6x equals 258. Divide by 6, and we know that x equals 43. So we know our rate for car 2 is 43 miles per hour, right in our chart there. And to find our rate for car 1, we have to do 43 plus 10, which is 53. Car 2, 43 miles per hour. Car 1, 53 miles per hour. Draw the picture. Car 1 went one direction. Car 2 went the other direction. The total distance was 288 miles. So we added our distances to equal 288. Example 2. 2 trains, one traveling at twice the speed of the other, start at the same time from stations that are 306 miles apart and travel toward each other. In 3 hours, the trains pass each other. Find the rate of each train. The first train, we can say the rate is x. The second train is traveling at twice the speed of the first, so its rate is going to be 2x. Our time for each one is 3 hours. Multiply to find our distance, so 3x. 3 times 2x. And if we draw a picture, we've got train 1 going this way, and train 2 coming this way. And we know that the stations were 306 miles apart. We're going to add our distances, and they are going to add up to 306. So 3 times 2x plus 3x equals 306. Multiply, and it's 6x plus 3x equals 306. 9x equals 306. X equals 34. So train 1 is 34 miles per hour. Train 2 is 2 times that 34. Train 2 is 68 miles per hour. Example 3. A bicycling club rides out into the country at a speed of 16 miles per hour and returns over the same road at 12 miles per hour. How far does the club ride out into the country if it travels a total of 7 hours? We know the rate on the way there was 16 miles per hour, and on the way back it was 12 miles per hour. We know that the total time is 7 hours. So we'll say that the way there is x, and the way back is going to be 7 minus x. Multiply to find our distances, 16x, and 12 times 7 minus x. And this is where they start and ride to here. And then they turn around and ride back. What can you tell me about those distances? Those distances are the same. So we're going to take our distances from our chart and set them equal to each other. 16x equals 12 times 7 minus x. Distribute. 16x equals 84 minus 12x. Add 12x to both sides, and we've got 28x equals 84. Divide by 28 on both sides, and we get x equals 3. So our time for the way there was 3 hours. Our time on the way back was 4 hours. But the question asks, how far does the club ride out into the country if it travels a total of 7 hours? So we're going to use our formula for the way there and our distance, 16x. But we now know that x equals 3. So we do 16 times 3, and that equals 48. They rode 48 miles out into the country. You can check it the other way as well. 12 times 7 minus 3. Our x value is 3. That's 12 times 4, which is 48. Our distances are the same. We are correct. That is section 4.6, Uniform Motion Problems.